Welcome to Tolleson Physics. So what we're going to do today is we're going to look at a spring a little bit more closely. What we really want to try to figure out is what affects the period of a spring. So we're going to derive that relationship now. And so when we look at a spring, we're going to we're going to look at what's the restoring force of a spring. So the restoring force of a spring is dictated by Hooke's law, which is the force of a spring equals the spring constant times its stretch. And we're going to associate that with Newton's second law, F net equals ma. So let's put those two together, and we get this relationship where ma equals negative kx. And so then what we're going to do is we're going to remember these equations that came from looking at the slope of a position time graph. And we're going to use that to substitute in for x and substitute in for a. So we're going to do that next. So as you can see, a equals the negative cosine function, and x equals the cosine function. And so we can simplify that, and a lot of stuff drops out, and we end up with the mass times the angular frequency squared equals the spring constant. Well, we want to know the period, so let's recall what the angular velocity is defined as. So angular velocity is 2 pi f, but I don't want the frequency, I want the period. So just remember, frequency is the reciprocal of period. So omega equals 2 pi divided by the period. So now I substitute that in the place for omega squared, and then I solve for t. And what we end up with is the period equals 2 pi times the square root of mass over the spring constant. All right, so does that make sense? So let's think about that. So the 2 pi and the is a consequence of how this is similar to a circle going around in a circle. But what about when mass increases? Should the period increase? Well, yeah, it should, right? So the more mass means there's more inertia, which means there's more resistance to acceleration. And so yeah, it takes it longer to go back and forth. Okay, so when the spring constant increases, should the period get smaller, right? It's a opposite, not quite inverse, but yeah, it should actually do that, because what does spring constant mean? The higher the spring constant, the stiffer the spring. If stiffer the spring, the bigger the force. The bigger the force, the higher the acceleration. And so yeah, that should actually decrease the time. Now, here's an interesting fact. The period in this particular case is not dependent upon a gravitational field. So you can actually use an oscillation of a spring or some other elastic substance to determine the mass of an object. And this is known as the inertial mass. It's the inertial mass because you're not using a gravitational field to figure this out at all. And therefore, you can do this, say, on the space shuttle, where you feel like you're in weightlessness. You can have something vibrate to determine the mass of an object. All right, so now I want you to consider this. So let's take a block with mass m attached to a horizontal spring with a spring constant k. Then it's going to oscillate back and forth with a period of t. So how do each of these things affect the period of the block? So let's stretch it, double its stretch. Let's increase the mass to double its mass. And let's increase the spring constant to 4 times the original spring constant. So hit pause now, think about that, and when you're ready to reveal the answers, hit resume. All right, so when you look at the equation for period, there's nothing to do with the stretch. The stretch has no effect on the period, which seems counterintuitive, but it is in fact true. Now, when you increase the mass, it's under the square root. So you're going to increase the period by a factor of the square root of 2. When you increase the spring constant, it's on the bottom, take the square root, and so it becomes half of the period. All right. So So you can determine the mass of an object without a gravitational field, and the period of a spring will actually help you do that. All right. So hopefully this helped you, and remember, keep on practicing.